Okay, Pate, today we are going to learn about what is the differentiation of hyperbolic function, right? The topic is differentiation of hyperbolic function. Differentiation of hyperbolic functions, right? Okay. So under that, initially the first differentiation where we can understand is d by dx of shin x, it's equals to how much? Cos x. We already proved this fact before, but anyway we'll just do a small review with that. We should know how to do the proof of this proof, right? So initially we know that shin x is how much? That is e to the power x minus e to the power minus x divided by 2, right? Okay, then if you differentiate shin x, that is the differentiation of how much? E to the power x minus e to the power minus x divided by 2. So from this differentiation I can take 1 over 2 out. It's turn up to then d by dx of e to the power x minus e to the power minus x. So you can write 1 over 2. If you differentiate e to the power x, answer is e to the power x minus e to the power minus x differentiation is minus e to the power minus x. So it's turn up to half e to the power x plus e to the power minus x. So simply you can say this is e to the power x plus e to the power minus x divided by 2. This is literally equals to how much? Cos x. That's a proof of differentiation of shin x equals to cos x. Then this part I'll just use a different color to represent. It's turn up to, if you differentiate with a shin any kind of function fx, answer is cos the same function fx into, again you need to differentiate the function given inside the bracket. We'll come up with some kind of example. Let's see if you want to differentiate shin 3x squared. Answer is cos 3x squared into, again you need to differentiate this 3x squared. So it's turn up to cos 3x squared into 6x. So your final answer become 6x cos 3x squared is the final answer for this case. Okay, the same way what we did in the previous section, only we can do this shin x, right? The same theory as before. If you differentiate cos any kind of function fx, answer is shin the same function into differentiation of it. But again, for example, if you work out, if you differentiate cos 4x cube, answer is shin 4x cube into, you need to differentiate this 4x cube further. So it's turn up to shin 4x cube times of 12x squared. It's turn up to 12x squared shin 4x cube is the final answer for this. That's a way of doing this. Okay. The next fact is, it's just like this. If you differentiate tan x, then answer is sec squared x. How do you prove this fact? So you know that tan x is, you can write shin x divided by cos x, right? Then we can use the quotient rule. It's turn up to cos x whole thing squared. Keep cos x and differentiate sin x minus keep sin x and differentiate cos x. That it's turn up to cos x into differentiation of sin x also cos x minus sin x into sin x divided by cos squared x. So you can write this is turn up to cos squared x minus sin squared x divided by cos squared x. That's turn up to we know that cos squared x minus sin squared x is 1 over cos squared x. This is literally similar to how much? Sech squared x. That is the answer for that. That's a way of differentiation of this. The same theory comes with the function fx. So if you differentiate tan fx, answer is sech squared fx into f dash x. That's the answer for that. Okay. For example, if you differentiate tan 4x squared, answer is sech squared 4x squared into differentiation of 4x squared is 8x, but it's turn up to then 8x sech squared x sech squared 4x squared is the answer for that. I'll just erase this. It's the answer for this. D by dx of sech x, it's equals to minus tan x sech x. So all these formulas are just like what we did in our normal trigonometric differentiation. Couple of negative and positive substitutions are there over here. That is a simple technique. So you can prove by the same technique using the quotient rules. We can get this answer, right? Okay. Now we will go ahead with couple of questions and see whether how to use this knowledge to do kind of differentiations with it. Suppose that we need to differentiate this kind of function. Let's turn up to x squared cos 4x. Cos 4x, right? Here we can use the product rule to answer this question. So I can put like this way: keep x squared and differentiate cos 4x plus keep cos 4x and differentiate x squared. So it's turn up to x squared times of cos 4x is sin 4x into differentiation of 4x is 4 plus cos 4x times of differentiation of x squared is 2x. It's turn up to 4x squared sin 4x plus 2x times of cos 4x is the final answer for this question. That's a way of doing this kind of a question. Right. Let's see. We want to differentiate this one. Pitamu, you get sin squared 4x. That means the differentiation of sin squared. That means sin 4x whole thing squared. Initial level just as 2, 3 just like test 3, sorry. Then initial differentiate the power 3 times of sin 4x to the power 3 minus 1 into, now you need to differentiate the term sin 4x. So it's turn up to 3 shin squared 4x times of shin 4x differentiation is cos 4x into differentiation of 4x is 4 puthe. The final answer is 12 shin squared 4x cos 4x is the final answer for this puthe. Okay, that's how it comes. Right, they can give you a question like this: if y equals to a cos nx plus b shin nx, prove that d squared y by dx squared is equals to n squared y. That's a way of proving, right? Okay, now let's see how to prove this context, right? Initially we can come up with the first differentiation dy by dx. You can keep a cos nx differentiation is shin nx into differentiation of nx is n plus b into cos nx is shin nx is cos nx, differentiation of nx is n. So it's turn up to an shin nx plus bn cos nx is the answer. So yeah, that's it. That's the first differentiation. Then we can say the second differentiation, d squared y by dx squared is you can keep an and shin nx is cos nx into n plus bn into this is shin nx into n. It's turn up to an squared cos nx plus bn squared shin nx. So you can see here, if I take n squared out, it's turn up to a cos nx plus b shin nx. That is n squared. We know that this part is similar to y. N squared y. That is a way of proving this theory. They might ask you, find the stationary point of the curve y equals to 12 cos x minus shin y. Minus shin x, right? Okay. To find the stationary point, we initially find dy by dx, the first differentiation. It's turn up to 12 shin x minus cos x. Then you can say at stationary point, what is the property we know? Dy by dx is equals to 0. That is 12 shin x minus cos x is equals to 0. Therefore, you can write 12 shin x equals to cos x. I brought this cos x to this side. Then you can say shin x divided by cos x equals to 1 over 12. You can write this is tan x equals to 1 over 12. Therefore, you can write x equals to tan inverse, I'll just write arc tan or tan inverse, whatever is fine. arc tan 1 over 12. How do you get this answer, Pate? So from our previous chapter, we already learned what is the inverse functions for this, Pate. So you can write arc tan x. What was the formula? That is half ln 1 plus x over 1 minus x. That was the formula, right? So this is turned up to 1 over 2 ln, you can write 1 plus 1 over 12 divided by 1 minus 1 over 12. Then it's turned up to x equals to half ln 13 divided by 11 is the final answer for this. Differentiating inverse hyperbolic functions. Yep, that's the next topic, right? Okay. Initially, the first differentiation we should know is if you differentiate arc sin x, it's equals to 1 over square root of x squared plus 1. We should know how to prove this theory, right? Now let's see how to do this proof, right? Initially we will get let y equals to arc sin x. That means dy by dx is equals to, that is the d by dx of arc sin x. So that is a point we need to work out. So if you find dy by dx from this function, that is the differentiation of arc sin x. So I'll start from here. Y equals to arc sin x. So I can write x equals to sin y. I just brought this arc sin to this side, sin inverse from to other side is sin y. Then I'll get from here you can write x equals to sin y. That means you can find dx by dy. Dx by dy is sin y differentiation is how much? Cos y, right? But I need the final answer in terms of x, right? Then we can see there's a relationship. This one, cos squared y minus sin squared y equals to 1. So using this formula you can write cos squared y is 1 plus sin squared y. That means cos y equals to square root of 1 plus sin squared y. Therefore, instead of this cos y, I can replace with 1 plus sin squared y, the square root of it. The sin squared y is how much? Sin squared y is x. It's turned up to 1 plus x squared, the square root of it. That is dx by dy. That means dy by dx is the reciprocal of it. It's turned up to 1 over square root of 1 plus x squared. That is the fact where we can prove. So that is a way of proving this theory. Right. Over here, we need to differentiate arc cos x is equals to 1 over x squared minus 1. You can use the same technique and you can prove this theory. Same thing what we did in the previous case, right? We'll come up to this. D by dx of arc tan x. Arc tan x is equals to 1 over 1 minus x squared is a formula for this. So we need to work out with this. So we will get let y equals to arc tan x. Therefore, you can write x equals to tan y. Then with that you can write dx by dy, it's equals to, what is the tan y differentiation? We are learning the previous part of it. Tan y differentiation is sec squared y. But we have a formula අපි ගත්ත පුතේ x equals to tan y. Sec squared y I know I can form a formula like this, but you can write the formula is cos squared y minus sin squared y equals to 1 පුතේ. So if I divide each and every term by cos squared y, what do you get පුතේ? So this is turned up to 1 minus tan squared y equals to sec squared y. Other than that, the same thing as 1 plus tan squared is sec squared x. With the similarly 1 minus tan squared y tan squared x equals to sec squared x. So instead of the sec squared x, I can write 1 minus tan squared y. That is the dx by dy, right? Then we can say dx by dy equals to 1 minus tan y is x1 minus x squared, 1 minus x squared. Then you can write dy by dx is the reciprocal of its turn up to 1 minus x squared. That's the format where we have to supposed to put, right? This is the formula. They might give you y equals to x arc cos x. Question is find dy by dx. So initially we can find dy by dx is equal to keep x, and differentiation of arc cos x is 1 over square root of x squared minus 1 into keep arc cos x, and differentiation of x is 1. It's turn up to then x over square root of x squared minus 1. Actually this is plus, so I made a mistake. Plus arc cos x is the answer for this. That's a way of doing this kind of question. Yes. The next question is we need to differentiate arc cos 2x. Cos 2x. The answer is arc cos x differentiation is 1 over square root of x squared minus 1. So it's turn up to 1 over, here the answer is x is replaced with 2x. 2x whole thing squared minus 1, the square root of it. After that, you need to differentiate this variable further. So your answer is 1 over 4x squared minus 1, the square root of it into differentiation of 2x is 2. It's turn up to 2 over square root of 4x squared minus 1. That's the first part of it. The second one is, if you want to differentiate arc sin x plus 1, right? The answer is, we know that arc sin x differentiation is 1 over x squared plus 1. So it's turn up to 1 over x is replaced with x plus 1 squared plus 1, the square root of it, into, again you need to differentiate this x plus 1. So the final answer would be 1 over x squared plus 2x plus 1 plus 1, the square root into 1. So your answer is 1 over square root of x squared plus 2x plus 2 is the final answer for this. Right. So if you want to differentiate arc tan 3x, so it's turn up to, according to the formula, it's turn up to 1 over 1 minus 3x whole thing squared into d by dx of 3x. It's turn up to then 1 over 1 minus 9x squared into 3. It's turn up to 3 over 1 minus 9x squared is the final answer for this. That's a way of getting the answer. You have to do another alternative differentiation. If you differentiate arc sech x, what would be the answer? Right. So it means initially I'll get y equals to sech x. Therefore you can write, sorry, I will get y equals to arc sech x. Arc sech x. Therefore you can write x equals to sech y. Right. Then initially I'll get dx by dy. What would be the answer for the differentiation of sech x? Differentiation of sech x is minus tan y according to this one, sech y. Right. Then instead of this sech y, I can replace x. Not a problem at all. Sech y is x. How to get this tan y? So here we have already learned this trigonometric relationship over here using this. The fact is it's just like this. What you can write instead of tan y? We know that 1 plus tan squared y is sec squared y. Therefore 1 minus tan squared y is according to Osborne's rule. There's a sign involvement. Therefore it's minus. It turn up to sech squared y. So instead of sech y, I can write square root of 1 minus tan squared y. Let's turn up to then instead of this, instead of this tan y, I can write 1 minus sech squared y is tan squared y. Therefore tan y become square root of 1 minus sech squared y. It's turn up to then square root of, I can write 1 minus sech squared y into x. It's turn up to then minus the square root of 1 minus sech squared y is 1 minus x squared into x. So for your final answer is minus x square root of 1 minus x squared is the final fact of it. In any case, if you want to get this differentiation, suppose that I need to differentiate this d by dx of cos x sech x. Right. Initially, I can use the same kind of product rule. Keep cos x and differentiate sech x plus keep sech x and differentiate cos x. Right. Okay. So I can keep cos x and differentiation of sech x is minus x square root of 1 minus x squared plus keep sech x and differentiation of cos x is we already learned in the first part of the differentiation of cos x is 1 over x squared minus 1. 1 over square root of x squared minus 1. Right. Okay. We can write this one as minus x cos x the square root of 1 minus x squared plus sech x the square root of x squared minus 1 the square root of it. Yeah, that's how you need to get this.